You may know about the Black Queen from chess. It's one of the most powerful pieces. But what do you know about the Black Queen hypothesis? Well, it's relatively recent, having been proposed in 2011 by Jeffrey Morris, but it functions as a branch of the reductive evolution theory. We think of evolution as the progression of a species becoming more complex over time and effective at survival on its own. But what if this looks like the opposite? Let's say that you and your friends decide to go hiking. You obviously have the best taste and you're tasked with bringing the snacks. Now, this means that on your trail, the rest of your friends don't have to bring snacks, and they can lighten their load. The snacks in question are what's known as a public good. This is essentially what the Black Queen hypothesis presents, except this friend group is more of a microbial community. If one member of this community is able to provide resources or a public good to the community, then the other members of the community can actually lose that gene or biological function to evolve. And in this sense, evolution looks like a streamlining of the genome, reducing redundancy and relying on the community to survive. Now, this all sounds good in theory, but there are downsides, and it's what's known as the tragedy of the commons. Let's say that on this hike, your friends keep taking those snacks and eating them until there's not much left for you or for anyone else. This is tragedy of the commons in a nutshell. The friends in question, or members of the microbial community that take the public good, are known as cheaters. I know, not the best of words. And if the public good is limited, the growth of the whole community is stunted. So, based on this, the idea of a utopian microbial community may work best in resource rich environments. But that still leads us to the question of why does all of this, the Black Queen hypothesis, really even matter? Well, it may explain why when we try to culture isolated organisms in a lab, they don't want to grow. We need to simulate their microbial community. And it gives us a better sense of how these biodiverse communities might be organized. Take biofilms, for example. They look like a sticky slime kind of material. They're actually secreted polymers. But the biofilms are actually host to a bunch of microbial life. A few studies have shown that phototrophic biofilms, that is, using sunlight for energy, assembled with both bacteria and algae, were more stable and quick to produce than those with algae only. It's important to note that the Black Queen hypothesis, at the end of the day, is just a hypothesis, but the growing body of evidence suggests that we should pay attention to this seemingly revolutionary way of viewing evolution. So maybe evolution really does favor collaboration after all, and it's not so survival of the fittest as we thought it might have been. Take that, Darwin, and thanks for watching.